Hi, welcome to this Oracle Code session. Today we will discuss REST in an asynchronous world. So the goal of this session is to discuss RESTful web services. Given that we are working with Java, we will base our discussion on Jax-rs. Now, this session will basically look at two angles. We will contrast and compare synchronous approach and asynchronous approach. Now, we will do that for both producing REST endpoints and consuming REST endpoints. So that basically means that we will look at what async and sync mean on the client side, but also on the server side. So let's first discuss the client side. So in the Java space, we have Jax-rs. Jax-rs stands for Java API for RESTful web services. It's a standard-based API that we can use to produce REST endpoint, and since Jax-rs 2, we can also use that API to consume REST endpoint. So if you look at Jax-rs prior to Jax-rs 2, Jax-rs was basically an easy-to-use framework that you would use to expose REST endpoint. It was part of Java EE. Having said that, you can also use Jax-rs outside of Java EE. So you can use Jax-rs just on top of Java EC. So prior to Jax-rs 2, you had an easy-to-use server-side framework to expose endpoint. But when it comes to consuming those endpoints, you basically had to write yourself the code to do that. And either you would use an API such as the HTTP URL connection from the JDK, which is a very old and very low-level API. So there was clearly a mismatch between the client side, so how you would consume the REST endpoint, and the server side. On the server side, you had a very easy-to-use API, a high-level API. So you had to do that either using a low-level API, or you could rely on third-party solution. This was solved in Jax-rs 2 with the addition of a client-side API. So now in Jax-rs 2, we have a server-side API that we can use to expose the REST endpoint, but we also have a client-side API that we can use to consume easily those REST endpoints. So today I will discuss about Jax-rs 2, which is the current version of the specification, JSR 339, which is part of Java E7. But again, you can also use Jax-rs outside of Java EE, so purely on top of Java EC. I will also discuss partly Jax-rs 2.1, which is the next version of the specification, which should be released during the summer this year. And that is JSR 370, which should be part of Java E8. Something which is important to mention, I will base my discussion on Jax-rs, and I will use Jersey because it's the open source reference implementation of Jax-rs. But given the fact that Jax-rs is a standard API, you can obviously use any compliant implementation, such as RESTZ, Apache, Wing, and so on and so on. So clearly, there's nothing really specific to Jersey during this session. So let's look at how the Jax-rs client API works. We first need to have a client instance. We get a Jax-rs client instance through this very simple bootstrap mechanism. So client builder new client will get us a client instance that we can use. Then from that client, we will have to construct a web resource target. A web resource target is just the location on the network where our remote endpoint is. Then, based on the target, we will actually construct the request itself. So in this case, let's say that we want to get the forecast of the city of Paris. So that's why we are setting some query parameters. We also use the get HTTP verbs, given that we want to get a resource from the network. And we also specify what response type we expect to get from the remote endpoint. In this case, this is a forecast class. And you see that the result of our invocation is indeed of type forecast. Now, given the fact that we have this client container, and this client container is a relatively heavy object, we need to make sure that we close that client container once we are done. So in Jax-rs 2, we have this new client API. It's a fluent API, so that means that it's a very easy to use API where you will basically chain all the method invocation to construct your request. So it's like a phrase where you actually step by step you specify what you want to do, what you want to get from your REST invocation. So the API in itself introduced different new objects, like the client container that we have already mentioned. So if you don't specify anything, it's basically convention over configuration. But obviously, you have the ability to customize that client container. We then have a web target, so a web resource target, which is basically some kind of glorified URI. It's basically the location on the network of our remote endpoint. You construct a web target from a client container. And the nice thing about the Jax-rs client API is that it basically shares a lot of the concept that we have on the server side. So we have the notion of path, obviously. We also have support for templates like we have on server side. We have support for query map parameters, matrix parameters, and so on and so on. So if you are already familiar with the Jax-rs server-side API, you will see that the client-side API is very simple to learn. We also have this notion of request invocation builder, where basically you have really the ability to customize your request. Like you have the ability to set the cookies, what media type you expect to get, set the headers, and so on and so on. Obviously, you also have the ability to define which HTTP verbs you want to use. Something to mention is that Jax-rs 2.1 is also having the ability to set the executor services. We will come to that later on. The flow of the invocation, as we have already seen, is very simple. So we have a client container. From that client container, we will construct a web target. And from that web target, we will construct our request and invoke that request to get a response. If we look at that example, it's basically the same example. The only thing is that this time we are specifying that we expect to get some JSON type in return. We also set some headers. And in this case, we don't want to have one single forecast, but we want to have a list of forecasts. So that's why we are using this generic type of list of forecast. Now, the Jax-rs client API has also the notion of invoker. So if you look at this example, this is the example that we have been using until now. We haven't specified an invoker. So that means that we are getting the default behavior. And by default, the invoker that we have is a synchronous invoker. So that means that this is a blocking call. So that means that as soon as the client, the get method is invoked on the client, that method will block until the response has been sent by the remote endpoint. So this is really a blocking call. The good news is that Jax-rs 2 has also an asynchronous invoker. An asynchronous invoker basically allows us to consume REST endpoint in a non-blocking fashion. To do that, it's exactly the same API. The only thing that we have to specify is that we need to specify that we want to use the async invoker. And you see at the bottom of the slide, I'm invoking this async method. So this is basically to tell that to the Jax-rs container that I want to use an async invoker. And the difference here is that as soon as we do the get invocation, the method will return directly. And if you look at the return type that we get from this request invocation, this is not a string anymore, but it's a future type of type string. So that means that we have a future object that we'll be able to use at some point to actually get the result of our async REST invocation. So to do a remote endpoint asynchronous invocation, we basically need to tell on the client side that, so we basically need to tell to our Jax-rs client container that we want to use the async invoker. To do that, we just need to use the async method while we construct the request. So you see that in this case, what we get in return is a future of string. So that means that we have a future object that we can query later on to actually get the result of our remote endpoint invocation. The problem is that if it takes a long time for the server to send the response, our call to the get method on the future object will be basically blocking, waiting for that result. And worse than that, if for some reason the server, if the remote endpoint is not able to send the result, our client application will wait forever for that result that will never come. So we need to make sure that we set a timeout. So this is the same example, but you see that this time we set a timeout of 5 seconds while we do a get invocation on the future object. So that means that this future object will be queried for maximum 5 seconds. After that, a timeout exception will be raised. So our application will not block even if the server is not able to send the response. But there's still an issue. So that means that our application might, in worst case scenario, be blocked for 5 seconds. So that means that basically our client-side thread will be blocked for 5 seconds. This is obviously a big issue because that thread is basically not able to do anything else. So if we are using that particular thread, for example, to update the UI, our UI will be frozen for 5 seconds. Given that it's a future object, we can do something like that. Instead of invoking the get on the future object, which is in itself a blocking call, we can check the isDone. And isDone is basically true once we have the result. So once the feature has completed or has been cancelled or an exception has been raised. That is a workaround to overcome that issue. But still, it's not very practical. Once we have, we are sure that isDone is true, we can actually invoke the get method on the feature object, which in this case we know will not be blocking. In this case, it's also a good idea to set the client container timeout because we want to make sure that the get request, so the get rest invocation doesn't takes too long. Something which is also part of Jax-rs 2 on the client side is what we call an asynchronous invocation callback that we can use. It's basically a very simple interface who has two methods. One method is completed, so that method is basically a callback that will be invoked when the asynchronous response has been processed. And the second callback is a fail method. That method is automatically invoked if an exception has been thrown, so if there has been an issue in the invocation. So it works like this. As usual, we construct from the client the web resource target. We are using the async invoker, given that it's an asynchronous invocation that we want to do. We are using the get HTTP verbs method, but this time we pass an instance of an invocation callback. Remember that invocation callback has two callbacks. The first one completed, so that's the invocation callback that is invoked once we have the result from the remote endpoint. The second callback is the fail method that will be invoked if something goes wrong. Now, if you look at the definition of the invocation callback, we have defined a parameterized type. In this case, this is a customer. So that means that what we expect to get from the remote endpoint is a customer type. You see that the return of that resource invocation is a future object of type customer. And you also see that the completed callback is expecting to get a customer type as parameter. Makes sense. That's what we expect to get back from the invocation. Now let's move on and let's put that into perspective. Here we have a simple microservices typical scenario where we have one travel agency services that will be the client of multiple backend REST services. The scenario is as follows. So we have a user coming in through the travel agency services, and that travel agency services would like to propose to that user some potential destination that he might want to visit. So the user gets to the travel agency services. The first services that will be invoked will be the customer services. So the idea is that we first need to have some kind of history for that given customer. Based on that, the travel agency services will invoke the destination services. The idea of that services is to provide some potential destination for that user. So that means that the travel agency has now a list of potential destination to suggest. And what we also want to do is that for each destination that we are about to suggest, we want to invoke the weather services and the quoting services to add some weather information to each destination, but also we also want to add some price information to the destination that we're about to suggest to the user. Once we have all those results, we basically combine them and send them back to the user. So the user would get a list of potential destinations that he might want to visit with, for each destination, a quoting, so a price information and some weather forecast. Now, obviously, given that we have multiple services to consume, we basically need to implement some workflow. So the travel agency services will have some kind of very basic orchestration layer to invoke the different services. So the first services to invoke is the customer services. Based on that, it will invoke the destination services. And once it has all the destination, it will invoke in parallel the weather services and the quoting services. So it's very obvious that a pure synchronous approach doesn't really make sense for such an approach. This is a very simple scenario, but still, in terms of performance, it would be very bad. Basically, the time it would take to get the result to the end user would basically be the addition of all the individual requests that the travel agency services has to do. So this is not something that we want to do. It's clear that we have to go asynchronous for that. Let's simplify that services and only look at two services. We just want to simplify the workflow and invoke the destination services. So we want to have some destination, and for each destination, we want to have some weather information. We want to do that in an asynchronous fashion. So if we look at the code, this would looks like this. We first do a request to the destination services to get some recommended or some suggestion. Obviously, we are using the async invoker. We have to specify an invocation callback. Remember, an invocation callback needs to have two callbacks. The first one is a completed callback that will be invoked once we have all the results from the invocation. In this case, we would get a list of destination, so a list of potential suggestions that we might want to provide to the end user. Then we would basically go over that list, and for all the elements of that list, we would do another REST request. Again, we have to do that in an asynchronous fashion, so we'll use the async invoker. Given that it's an async invocation, we have to specify an invocation callback. An invocation callback needs to have its two callback defined. So the first one is the one that will be invoked whenever we have all the results. Now, we also have to make sure that we provide the failed callback for the two async requests that we are doing. So we would have something like that. So I guess that you see that that kind of code is getting a little bit difficult to write, and that means that at the end of the day we would have a code that is difficult to write, debug, and maintain. You also see that the error handling is basically spread across our code, so it's clearly something which is a bit difficult. And why is that? Well, we said that we want to go asynchronous because we want to get the performance. and the scalability. We don't want to be blocking. To do that, we have to use the Asynchronous API. But given that there are dependencies between our services, we see that this API doesn't really fit that model where we have to invoke in an asynchronous fashion multiple services, and each services has dependency between another services. So it doesn't really work. Jax-rs 2 has two invokers. The default invoker, which is a synchronous invoker, so that means that it's blocking, and it has also an asynchronous invoker. This is the async method. Jax-rs 2.1 is adding a third invoker. It's a reactive asynchronous invoker. It's the Rx method that you see at the bottom of the slide. And you see that when we are using that invoker, what we get in return for the request invocation is of type completion stage. So let's quickly talk about the completion stage API. It's a new API that was added to Java EE 8. And the nice thing about that API is that it has the notion of a stage. A stage being an operation, a computation that performs an action or computes a value in an asynchronous fashion. And we have the ability to basically chain different stages. So we can define a flow of different stages that needs to be invoked in a specific order. So on termination of a stage may in turn trigger another dependent stage execution. Now, if you look at the completion stage Javadoc, the API in itself might seem a little bit daunting. It has a lot of methods. It has around 40 methods. To grasp the API, you just have to understand a few concepts. And for each concept, there's basically a keywords. And that keywords will basically be used to construct the method that you're going to use. So that's why we have a lot of methods. But at the end of the day, those methods are just basically a combination of different behavior. For example, on one stage execution, we may trigger another stage. So if you just want to trigger the execution of another stage, you will use the then keyword. But if you want to trigger the execution of a given stage once two given stages are completed, you would use the combine stage. And if you want to trigger the execution of a stage when one of the two completion stages are done, you will use the either keywords. So other concept that you have to know, does the computation takes an argument and returns a result? For example, we have the apply keywords, so that means that you are going to supply a function with the result of the previous stage as argument, and that function will return a result. You have the accept keyword. That one takes a consumer, and it only takes an argument, so it doesn't return anything, given that it's a consumer. You also have the run keywords. That takes a runnable, so it doesn't have an argument and it doesn't return a result. Another concept with its keywords that you would have to understand is how the execution of the computation is arranged. So if the method doesn't end with the async keywords, that means that we are using the default execution facilities. But on the other hand, if the method ends with the async, that means that we want to use the stage default asynchronous execution facilities. And in addition, you also have the ability to pass specific executor services. So basically, to use the completion stage API, you will have to combine those different keywords to basically obtain the method that you want to use. So for example, you have the then accept method. Then if you want to perform that in an asynchronous fashion, you have the then accept async, or then accept with the ability to pass an executor, and so on. Or you might have the then accept both if you want to wait for the execution of both completion stage before triggering another completion stage. Or then accept both async method, and so on and so on. So to get the completion stage API, you really need to understand those different keywords, and then it's just a matter of using the right method. If we look at an example, we have a first request. So this one is a request to a remote endpoint to get some pricing information for a given destination. You see that we are using the Rx invoker. And then we have a second request. This one is used to get the forecast information for a given destination. And again, you see that we are using the Rx invoker. So that means that what we get in return is two completion stage. When both stage completes normally, the two results are passed to the function that we have here. So that's why we are using the then combine. So basically we have the first completion stage, and we want to execute that one and the second completion stage, so the CSF. Once we have the result, they are passed to the function, which in this case is a reserve if affordable method that get as parameters the two results of the invocation. So the following example obtains in parallel, so in an asynchronous fashion, a price and a forecast for the destination, and it makes a reservation if some specific conditions are met. So this is basically new in Jax-rs 2.1. We have this new Rx invoker that allows you to consume in an asynchronous fashion remote REST endpoint. And the nice thing about that API is that we are using the Java EC8 completion stage API to basically define the dependency between the services that we want to invoke. The completion stage is supported out of the box in Jax-rs 2. All the Jax-rs implementation, all the Jax-rs 2.1 implementation must support the completion stage API. Having said that, the goal of the specification is to make it extensible and open to third-party frameworks. For example, the Jersey plans to add support for RxJava. Let's look at a quick demo to illustrate this. So what I have running on my machine is basically these travel agency services. It's one of the Jersey sample. That sample has basically all the services needed to fulfill that scenario. So we have the travel agency services, and then running on the same machine we have the multiple backend services, the weather services, the destination services, and so on. This is the GitHub page of that sample. So basically we have agent services. So this is basically the travel agency services, and it has multiple implementation. It has a synchronous implementation. So the travel agency services will consume all the backend services using the traditional synchronous approach, so the blocking one. There's also an asynchronous approach. And finally, we will also use the completion stage agent, so the one using the completion stage API. If we look here, we also have remote services. So these remote services are basically the backend services. For example, we have this one, remote destination visited, who will give us a list of visited services. So if we go to the URL, so I'm going to my local machine here for 1990. Let's see, Rx remote destination visited. I should have just, so this is what I get. So some history. So this is just the result of one services. On the other hand, if I'm asking for recommended, so that's basically where the user has to, what destination will suggest to the user, we have some results, and so on. And for example, I can also ask some specific forecast for one given destination. So I just need to give a city here, and this is just the result of one invocation. Let's now invoke the traditional the travel agency services using the pure synchronous approach. So I'm using the synchronous agent, and we see that, well, it takes a bit of time. Okay, now we have the result. So that is the result that is composed of the various invocations from the multiple services. So we have all the history, and we have a set of recommendations. And you see that for each recommendation, we have not only the destination, but we also have some weather some forecast information and some pricing information. And we have that for 5 times. What is interesting is at the end, we also have the total processing time. And we see that for the buckling approach, to invoke all those services basically in a serial fashion, it takes more than 4 seconds. Same approach, but using now this time the Asynchronous API of Jax-rs 2. And we're going to have all the result. We see that it was quite faster. So we have all the destinations that were visited, and we have a set of suggestions with each time forecast and pricing information. And the processing time is under 1 second. So it's really faster. And last but not least, let's use the completion stage API. And again, it was very fast. So we are going to have all the results, all the destination. And the processing time using the completion stage is basically more or less the same as the asynchronous approach. The takeaway here is that in terms of performance and scalability, you should go asynchronous approach. And then you have two choices, either using the traditional asynchronous API or using the reactive asynchronous API. And in terms of performance, you will basically get more or less the same performance. But clearly, if you have dependency between your services, and that's what we have here. So for example, it doesn't make sense to invoke the weather services before having the list of suggested destination. So if you have dependency between your services, then your code will be a lot easier to write using the reactive asynchronous API. So in summary, we have in Jax-rs 2, we have a client API that we can use to easily consume REST remote endpoint. We have this client-side container that basically hides a lot of the complexity for us. So it's a high-level API that we can use. It has multiple invoker. It has a synchronous behavior. That's when you are not specifying any invoker, you will get the default invoker, which is blocking. We have also an asynchronous invoker. That's part of Jax-rs 2. For that, you have to use the async invoker. You see that in some case it might block. So even though it's async, it might block because remember that future get might just block waiting for the answer. So if we want to get around that, we can use the invocation callback facilities that is part of Jax-rs 2.0. But we saw some limitation typically when we had multiple services to invoke and when we had dependency between the services. So it was not really easy to write such a code. So that is something that is being solved in Jax-rs 2.1 with the new reactive invoker. That's the Rx method that we are using to get the reactive invoker. Let's discuss server-side REST. To expose REST resources endpoint using Jax-rs, we would have to do something like this. We have a class with a few methods. We are using the add path annotation to specify at the class level to specify that this is the URI for all the resources from that method. And then we can also use the same add path annotation on a given method to specify the subpath. In this example, I'm also using a path parameter that will be resolved at runtime. And finally, I'm using the add produce annotation to specify that this particular REST resource endpoint is producing that specific media type, XML. Note that I haven't specified any HTTP verb, so that means that I'm using the default one, which is get. And as you see, I have the ability to use different verbs, like post, in this example. So in this case, my REST endpoint is producing XML, and it consumes XML. Also note that I'm using some query parameter in this particular example. So this is standard Jax-rs code that we have been using since years. Now in Jax-rs 2, we also have the ability to use asynchronous capability on the server side. So it works like this. So we have a Jax-rs resource method, and note that we are injecting, using the add suspended annotation, this new object, an async response. Also note that this method is returning void, so it doesn't return anything. So we now have this Jax-rs response that we can basically use to basically do the request processing in a different thread. So what I'm doing here, let's say that I'm in a Java environment, so I'm using a manage executor services to start a new thread. In that thread, I would do something that would likely be very expensive in terms of resources. So I have an external thread. I'm running some very long running computation, and then I have this async response object that I can use in my external thread to basically resume the thread that was processing the incoming request. All of that is done using this new async response object. This approach gives us the ability to execute the business logic in a different thread. Something important to mention is that the underlying IO thread is still blocking. So that means that my client is still blocked until my async response is resumed. This is true on both sides of the connection, so on the server side and on the client side. We have this new async response, which now provide a means for asynchronous server-side response processing. So we have the ability to do the processing of the response in a different thread that we create. It's injected using this new @suspended annotation, and we have different way of working on that async response object. So typically, we inject the async response, so we basically suspend the thread, we do the processing in a different thread, and in that different thread, at some point, once we have the result, we would resume the execution of the request. So basically, we would ask to send the response back to the client. We can also cancel the request, we can also configure the request to set some timeout, and so on. The thing that is key and that is really important to keep in mind is that the underlying IO thread is still blocking. And it will be blocked until the response is being sent to the client. And the client will block until it has the response. So that is a key aspect to keep in mind. So if we try to look at a basic schema that would depict how it works, we have a client that would issue a request. On the server side, we have our Jax-rs container that would process the request. And then on both sides of the connection, the threads are blocked. So that means that on the server side, the IO thread, which is in orange on my slide, is blocked. So my Jax-rs application is running. At some point in time, one of the Jax-rs method will basically suspend the request by injecting the @suspended async response object. We now have the ability to do the processing, so the business logic to get the response in a different thread. So typically, if we are in a Java environment, we do that using a manage executor services and manage thread. That's an example. Once we have the result available from that external thread, we would use the resume to basically send that to the client. Until then, the client is blocked and the IO thread on server are also blocked. So we invoke the async response resume method to basically resume the execution of the response. And the Jersey container is now able to send the response back to the client. And until then, the client is blocked. Now that the client has the response, its thread isn't blocked anymore, so it can continue to work. This is something that we are typically use on the server side when we have long-running REST operation. So it works like this. So we do a post request, some long-running operation happen, and then at some point in time, we send a response back to the client. So we would send something like a 201, the resource has been created, and here's the location of the resources. Now, we might want to use different patterns to solve that use case. So same approach, the client do a post request, and then the server would answer directly with a 202, which is basically mean I've accepted the resource creation, but I know it will take time. So what the server will do, it will tell the client, okay, I will now work on creating that resources, but I know that it will take time, so please come back later to see when this is done. The server would also send some temporary location that the client can use to get basically the status of that resource creation. So that means that the client has the ability to issue request against that temporary resource using the temp location that was sent back to him. And then the server would answer something like 200, so that means OK. So this is a valid temporary resource. And the server has also the ability to add additional details, like, for example, I'm expecting that resources to be available in the next 20 seconds. So it would basically give an indication to the client when it can expect the resources to be available. So, and then the client at some point in time will do a request against the same temporary location. And if it has been created, the server, so the REST server endpoint, would issue a 303, which is a C header. So it basically means that the request has been created, and it's basically a redirect to the new array of the resources which has been created after a post. So that response would include not only the 303, which is a redirect, but also the location of the final location of the resources which has been created in the first place. So this is something that we would use when we have a long-running operation. This is popular patterns for solving that case. So it basically avoids to the client to have to wait in the case where resources takes a lot of time to be created on the server. Now, let's talk about something that might be useful in that specific use case, and that is server-sent event. So SSE is a widely used mechanism that is basically used to send payload from the server side to connected client. This is something which is widely used on the web. There is a well-defined standard for that. It's one-way only, so that means that the client establishes the connection. Once the connection is established, the server has the ability to push from the server some payload to that connected client. So the client has no way to push notification from the client to the server. This is really one way only. But we could typically use that mechanism to allow the server to send some notification to the client, for example, when a long-running operation is done. So SSE is something that has been added to Jax-rs 2.1. So the Jax-rs 2.1 is introduced different new objects like SSE event. So an SSE event is basically a representation of a server-sent event. It's a super interface that is extended by two interfaces. On one hand, we have outbound SSE event, which is the server-side representation of an SSE event. And on the other hand, we have inbound SSE event, which is the client-side view of a server-sent event. So on the server side, we have the ability to create event. On the client side, we don't have the ability to create event. Again, this is one way only. So on the client side, we are just consuming server-sent events that have been pushed by the server. If we look at the API, we have this new SSE event sync object, which is basically a connection between a server and a client REST endpoint. And that is used to stream SSE event. So this is basically the server-side view of an SSE connection. The API allows us to group multiple connections, so multiple SSE event thing in one object, which is a broadcaster, an SSE broadcaster. And the idea is that an SSE broadcaster is just a collection of a connected client. So if you are pushing a payload to an SSE broadcaster, it will be automatically pushed to all the connected clients. If we look at how it works using the SSE API, we'll see that it's very simple. So we have this method. We inject two objects. The first one, so this is the server-side view. So on the server, we are injecting the SSE event thing, which is the connection between the server and the client. And we are also injecting this SSE object, which is a convenient object that we can use, for example, to create easily SSE event. Then all it takes is to basically leverage the existing Jax-rs annotation. So we are using the add get annotation. In this particular case, our SSE endpoint will be exposed using the SSE endpoint, and it produced that specific media type, server-sent event media type. Then our method do something, and obviously at some point in time we're expecting to push some payload to the client. for example, to tell the client that that long running operation is done. So now the client can fetch the actual and definitive resources. And to do that, we just need to invoke the send method on the connection object. So in this case, event_thing.send. And obviously, we have to send some actual payload. So for that, we are creating an event. And we can use the SSC object to that gives us a shortcut and an easy way to create some SSC event. We can do that multiple times as needed by the business logic of our application. So here the idea would be to send notification to the connected client to specify that that specific long running operation is done. And obviously at some point in time we would have to close that SSC connection object. Now if we look at the client side, we also have an object that represents the connection, but now from the client to the server. So it's called SSC event source. To consume SSC event on the client side, we are using the Jax-rs 2.1 client side API. We need to first create a connection. So SSC event source, we set the web resource target of our SSC endpoint. We have the ability to configure that connection. So in this example, we set the reconnecting interval to 5 seconds and so on. And we'll see, we need to make sure that we actually invoke the build method to actually construct that object. So we now have our connection. What we have to do next is to register some callback. The first callback that I'm registering in this example is an inbound SSC event consumer. So it's basically a consumer that will consume incoming event. In this example, the only thing that my consumer is doing is just print what is being sent. And I have the ability to register different consumer. For example, I can register a throwable consumer that will be invoked if something goes wrong. And finally, what I need to do is to invoke the open method on the SSC event source, so on the connection itself. So that's basically where I tell my container that I want my client-side container to establish the connection to my remote SSC endpoint. And the container, the client-side container, will do all the heavy lifting for me. So it will establish the connection, it will register all the callbacks, and so on. And as soon as my connection is established, anytime some payload is being sent from the server to the client, my inbound SSC event consumer will be automatically invoked for me. And obviously, once I'm done, I need to make sure that I actually close my client-side connection. So the idea is that Jax-rs 2.1 is adding SSC support, and it might be useful to use SSC support when we have on the server side long-running operation. Let's wrap up. So today we have discussed Jax-rs. Basically, we have talked about mainly about Jax-rs 2.0, which is the current version of the specification. It's part of Java E7, but we can also be used just on top of Java EC. And we have also discussed some of the Jax-rs 2.1 new capability that are part of Java E8, but again, they can be used in just Java EC. So the two new capability that we have discussed are the new Asynchronous Reactive Client API of Jax-rs 2.1 and also the introduction of SSC support. So Jax-rs is a standard-based RESTful framework. It has support for the server side since the beginning, and since Jax-rs 2 we have added support for a client-side API. That it's standard-based is the fact that you can basically choose which implementation you are using. Today I've used Jersey, but I mean you take that code and basically it should work on any standard Jax-rs implementation. On the client side, we have discussed the client-side container that basically do all the heavy lifting for us. So it provides a very high level and simple to use API to consume REST endpoints. It has 3 invokers in Jax-rs 2. So in Jax-rs 2.0 we have a synchronous capability, which is the default invoker. We also have an asynchronous invoker. And in Jax-rs 2.1 we are adding a third asynchronous reactive invoker. And typically, you would use that reactive invoker when you have multiple services that need to be invoked, and when there are dependency between those remote services. In terms of performance, I think that it's fair to say that the pure asynchronous invoker is as fast as the asynchronous reactive invoker. So it's only really when you have a dependency between services that you really need to look at the new invoker that will be part of Jax-rs 2.1. That reactive invoker is using the Java-EC 8 completion stage API. This is mandatory per the Jax-rs 2.1 specification. But having said that, we also recognize that there are already external solutions out there. So the specification is open to third-party reactive frameworks. So for example, Jersey support today RxJava 2, and listenable features from Guava. And the only thing that is mandated is the support for the completion stage API, and it's really up to the implementation to decide which additional frameworks they are going to support. We've talked about Jax-rs on the server side, so we saw this this capability, this async response capability that has been added in Jax-rs 2, that basically allows to resume the execution of a request processing from a different thread. We also discuss a pattern that is used for long-running operation to avoid that the client is blocking for a long time. And finally, we have discussed how a servers and event, which are part of Jax-rs 2.1, might be useful when using that patterns. Today, the focus of the presentation was really Jax-rs 2, and also we have discussed some of the capability of Jax-rs 2.1, which are part of Java 8, but Java 8 is really broader than that. For example, in Java 8, we have the Servlet 4 API, which had support for HTTP2. We have a new binding API to do marshalling and unmarshalling of Java object to and from JSON document. We have CDI2, which had asynchronous event capability, which is something that might be very nice used with the Jax-rs 2 Rx API, given that the async capability of CDI2 support also completion stage API of Java EC 8, and so on and so on. So there are really a lot of new stuff in Java 8. Java 8 is about modernization of the platform and simplification of the platform. This is still work in progress. The goal is to finalize Java 8 this summer. We have the open source reference implementation of Java 8, which is Glassfish 5, that will be finalized shortly after that. But in the meantime, you can already have access to the different Java 8 reference implementation, like Glassfish, but also Jersey and others. So that means that today you can already play with the API that will be part of Java 8, including Jax-rs 2.1. And in fact, we have recently moved all the Java development and the Glassfish development from java.net to GitHub. So just go on github.com/javae and you will have the ability to look at the different specifications, which are some are already finalized and some are in a draft form. And so you can already have access to that and have access to the reference implementation. And the idea is that we would like to get your feedback on that before it's final in the summer. So I will conclude with some resources that you might want to check to learn more about this. The first one is Jax-rs specification. I also encourage you to check the different examples that are in the GitHub repo of the Jax-rs repository. You might want to check the Jersey documentation, which has a lot of details about the asynchronous capability of Jax-rs. So we'll now conclude with a question and answer. So feel free to raise your question and we will answer them. Thanks.